Welcome back. So today we'll be making Sierpinski's triangle. Basically, self-repeating triangle within itself. We can read the rules. So we have an equilateral triangle to start with. We subdivide it into 4 different triangles. So we can see it here, top, middle, left, and right. And then we remove the middle one and we repeat the process for the 3 that are left. It would look something like this, right? So every time I press the space bar, we get a subdivision being done on the smallest triangles, right? So here, so on and so forth, right? So I'll go to the whiteboard to explain what's going on there. Okay, so we have our canvas right here, and we will have a triangle, right? An equilateral triangle. The important thing to do is I was thinking of creating a class, right? Triangle. So we are going to need 6 points that are needed for the Sierpinski triangle. So the first 3 are the 3 points that you need for a triangle, and then we're going to need the middle points of all of those 3 points, right, between them themselves, right? So those other 3 points. So I was thinking just to have P1, P2, P3, P4, P5, and P6, right? As P vectors, right? Just vectors, so X and Y values inside of it. Right. So I was thinking of having that, and in the constructor of the triangle, I was thinking of just passing it P1, P2, P3, and that's it, right? Because with those 3 points, we can figure out the 4, 5, and 6. So 1, 2, 3 would be 1, 2, and 3. And then 4, 5, 6 would be 4, 5, 6. Right? So that's what I'm thinking. And to get, let's say, to get P4, right? So we have P1, which let's say it's 200 x and 0 width, right? And we have P2, which is in this case, let's say 150 width and I don't know, maybe 200, or maybe it's 1, right? There, it doesn't matter. So this is X and this is Y. So to get the P4 that we need, we can lerp the values of both X. So this would not be this, sorry. So this would be, let's say, 400 and 200 over here, right? It doesn't matter really. So I was thinking we would have, we would lerp, so basically finding a value between those 2 values. So lerping the value to 0.5, right, to 50% of that value. So we can just add the 2 value, divide by 50%, but we have a function in processing called lerp, right? So we're going to use lerp. We're going to pass p1.x and p2.x and also, sorry, forgot, and also 0.5, right? So 50%, right? So this is going to get us the x value. So x equals this, right? And the y value, it's pretty much the same, right? Though it's going to be y and y. So we can get each of those points by doing this. So I was thinking of we do this within, so we only pass 3 points to the constructor class, and then we just have to, in the constructor, calculate the 3 other points. So that's pretty much it for the base of the triangle. We also need, let me draw a line. So we also need within the triangle a divide function, right? Oh, also I was thinking we could keep track of if it's divided or not, right? So divided, and by default it's false, right? So it's not divided by default. So we would have here a function divide. It wouldn't receive anything. What this function would do is we're also going to need to keep track of the other three triangles, right? So whenever we do divide, we need to keep track of these triangles inside of our original triangle, right? So we could have like an array of triangles. Right. So we'll need to keep track of those triangles. So in divide, we can just create, so we check first if it's divided already, but if it's not divided, let's say, we create three new triangles, a new triangle based on the points that we need, which we should already have since they are created in the constructor. So we create three new triangles and we add those, or we set those into the array. And then after this, we can have an else. So if it's already divided, we just call divide on those triangles. So that's pretty much it for the divide. And we're going to have a show function to just display the triangle, right? So we're just going to say display this triangle, and then if divided, then call show for all of the triangles in here, right? So that's pretty much the concept. So we'll go ahead and do that. All right. So first thing first, let's create the triangle class like we said. Awesome. So we said we will have 6 points, sorry, vector. There you go. So P1 and up to P6, right? So P1 is the top one, P2, bottom right one, P3, the bottom left one. P4, it's the middle right one, P5, middle bottom one, and P6, middle left one. Awesome. So we will also have the, we said we wanted to keep track of if it was divided. So let's have a boolean called divided. Let's set it to false by default. And we will also need to keep track of the other triangles in here, right? So triangle, it'll be an array, and let's call it triangles. It's fine. Let's create the array right now. Since we know the size of it, it's going to be 3 always. We're only going to create 3 triangles from the 1. Okay, that's pretty much it in terms of attributes. Now let's create the constructor like we said. So awesome. So we said we're going to pass it 3 points to begin with, the original ones. So P1, P2, and P3. That's pretty much it. Awesome. We can set those. Awesome. Okay. And now we need to calculate the other points that we're missing. So this is the P4. Needs to be a new P vector. So we said for the X value, let's take a look back at the whiteboard. So we said it's for P4. We just need to lerp for X and for Y the P1.x, P1.y, and the P1.x, P2.x at 0.5, so at 5% of that distance, and do the same for the other two, right? So let's go ahead and do that. So we need to lerp, so we need get to, we'll need to get to 50% of the value between p1.x and p2.x. And it's going to be the same, but for y, there we go. Awesome. And we can do the exact same for the other two, right? So 5 and 6. So 5, we know it's the middle bottom one. So we know we need the P2 and the point between P2 and P3, right? So between P2, we said, and P3. There we go. That's pretty much it. And then for the 6th point, which is the middle left one, we need between the P1 and the P3, right? So we already have P1 right there and the P3. There we go. So that's it for creating those points. Awesome. So let's do the divide function first. Right. So we know that we need not to be divided, right? So if it's divided, we'll do something else. And if it's not divided, then we need to divide, right? And like we said, we need to divide and put them into the triangles array, right? So triangles index 0 equals something, and same for the other two, right? So 1 and 2. Awesome. So we need to create a new triangle that is, so if we take a look at the whiteboard, so the first triangle we need to create is, let's say it's going to be this one, right? So this would be the first triangle. So we need to get the P1, P4, and P6, right? So P1, P4, P6. This is our new triangle. Let's do that. And we need to have them in order as well, because we're using the order in here as well when creating the new points, right? So it's going to be P1, like we said, P2, P4, and P6, I believe. Yes, it is. Awesome. So that's it for the first triangle. Then let's do the same for the bottom right one, bottom right triangle. So in this case, it's going to be P4. And then the middle bottom one, which is P5, and then P2, and then so 4, 2, 5, yes, 5, P5, that's it. Okay, and then again, so this time it's going to be the bottom left one, which will be 6, 5, 3, right? Because, like, again, let me go back, right? So 6, 5, and 3, right? And we must start from the top point of the triangle itself that we want to create. So the P1 of that new triangle will be the P6 of its parent triangle, right? We could set it to 5, but that would mess up after when we divide again, right? So P6, P5, and P3. P6, P5, and P3. There you go. So that's it. Now, okay, good. And we set divided to true. Divided to true. Okay, great. We're almost there. When it is divided already, we can just divide the subsequent ones, right? So it's called divide for them. So 1, 2. Awesome. So that's our divide function. That's all it does. Then we need to show those triangle, right? So we could pass the colors, but I'm just gonna hard set black and white for the colors, right? So what do we want to show? We want to show the, so first thing, let's do just the 3 points that are the default 3 points that we have. This is the triangle, right? So let's do fill, and we'll fill the spaces where there is triangle with black, and the rest with white. So we'll have fill 0 and then a triangle at p1. Well, this dot. I'm just going to do p1 just because there's a lot of them. P1.x, p1.y, p2.x, p2.y, p3.x, and p3.y. Okay, that's it. That's the triangle. And as it's said in the, well, no, okay, yeah. So that's it. Okay. Now, if we are divided, right? Right. We need to also show the subsequent divided triangle. So, and if we take a look back at here, it says subdivide it into 4 smaller parts and remove the central triangle. So whenever it's divided, we need to remove the central one. So let's do it. We need to fill, so to remove it, I'm just going to interpret it as showing it white. And we need to remove it. So that's it. So it's going to be a triangle again, though this time it's going to be basically all of the points, all of the other points, right? So 4, 5, 6, 4, 5, 6. So p4.x, p4.y, p5.x, p5.y, and p6.x, p6.y. Awesome. Great. And we can call show for the other triangles as well. Let's copy this there. Dot show. Awesome. Great. So we're pretty much done for this. Yeah, I think we're done with the triangle class. Great. Now let's draw them. Okay. So we need first to start with, most important will be to get an equilateral triangle. So let's do void setup. And we know we want at least one triangle being like the main triangle. Let's call it T, just because triangle is already taken like this. So let's just call it T, right? And we'll do a square. So size being, I don't know. Let's do 800 by 800. Sure, that's fine. Let's do no stroke as well, because we don't want to show the stroke. It doesn't need to be there. Okay, great. So let's first create a triangle. New triangle. Okay, now we need the 3 points, right? So we need a 3p vector. P1, P2, and P3. Okay, so we know the first point, the middle, the top middle one, it's going to be the width divided by 2, right? That's pretty straightforward. So width divided by 2. Awesome. Now, for the x value, right? For the y, it's just at the top, so it's 0. So for the other two, we have width and height, and we have 0 and height. Great. Awesome. I think that's it for the triangle points, right? So P1, P2, and P3. Awesome. Let's just show it to start with. See if we do have it displayed properly. Seems to be fine. Let's make the background white as well, since we said that everything we're going to remove will be white. So let's make the background same color. Okay, let's see. Okay, good. Now let's just try to I don't think it's equilateral right now. We could we could probably cheat and just do for and a for loop that goes from from 0, but I mean, it's not a perfect equilateral triangle right now. It doesn't matter to me right now for the moment. We can fix this afterwards if we want to. Let's try to divide and show again a couple of times, right? So t dot divide and show it after we divide. Let's see it. Okay, that looks good. Let's try this again, right? Whoa. Let's try this again. Couple of times. Okay, I think we're pretty much done with it. What I would do is probably show it once and then do the key pressed or mouse pressed event, right? It doesn't really matter. And I'm going to do key press if the key is the spacebar, right? So if key code is 32, 32 is the spacebar. So if you press the spacebar, then it's going to divide, right? Divide and show itself, right? So t dot divide. There you go. Awesome. So if we try it right now, I'm pressing the spacebar, but it's not working, and that is because we haven't set the draw function. So whenever you do want key press events to go through, you need to set the draw function, right? So now it's working, right? One thing I'm thinking to be more efficient, we could not have to draw this if it's already divided, right? If it's already divided, we don't need to draw this. We can just draw it once, and the other ones are going to be drawn on top of itself, so that's fine. Let's see it. Okay, it's still working as expected, so that's all good. There we go. Yeah, so that's pretty much the Sierpinski triangle. You can probably do it, do a better implementation of it. I was just, I don't know, maybe lazy. This is definitely not equilateral triangle, but doesn't matter. So yeah, that's pretty much it. Let me know your thoughts in the comments, and see you all guys next time.